Okay, welcome to chapter 11. We're in 11.1.2 today. We're going to talk about the surface area of a pyramid. Surface area. The assignment, the first part of it's in 11.1.1, the second part's in 11.1.2. Some terms you definitely should know. Biggest one here is pyramid, of course. And I think most of you know what a pyramid looks like. A term that you might not be familiar with would be the apex, would be the top of the pyramid. How would you find the surface area of a pyramid? So here's a pyramid for you. What do you think, what information? Now surface area, remember, that's like we're painting it. So that's the outside of it. What do you think we would need? Well, one thing that we would need, this is, remember over here, this is called a net. We've talked about a net before, and that's a pyramid taken apart in this case. Well, we'd need the base, okay, and we'd need the different sides. So we have, in this case, 1, 2, 3, 4 sides. Well, to be able to find the area of each side, you're going to need something called a slant height. Okay, and if you drop from the apex to the base, you drop that height down, and you have a slant height which goes that bisects the side right here. You can actually create this right triangle, and the slant height or the height can be found by using the Pythagorean theorem. So if you look at what I have down here, if you focus on this right here, that's what each of these would be. Here's one of them, here's another, a third, and a fourth. In this case, all of them are the same. It gets really fun when they're not all the same. And then of course here is the base. So the main focus here is to find the area of the different sides. Now this doesn't look like a square pyramid, but it is. So you got to trust me on that. So the surface area, first thing I need on here is the base. Okay, and so the base in this case is a square, so it's length times width, and that's 10 times 10, which is 100 square meters in this case. Okay, now I need this triangle here. Well, if I have this triangle and if I know that this is, well, now this is a square, this is sitting directly in the center of the base. So that's halfway across. Here's the other half right here in case you didn't know. So if the side length is 10, that's 5. So now I'm actually looking at this triangle right here. The height is 12. That base is 5. There's my right angle. And by using a little Pythagorean theorem, I know that this is 15. That is my slant height. Okay, that's 15. Well, now what I'm looking at here is the idea of, if I take this side right here, okay, I know that the height is 15, I know that the base is 10, and I have that triangle. So the area of the side of that triangle is 1/2 base height, in which in this case it's 1/2 times 10 times 15. Well, that comes to 65. Well, this side here is exactly the same. And same with the other side and the back side. So then I can take 4 of those, because in this case there's 4 of them, 4 times 65, and if I add that to the base, that's going to paint all of the sides. And it comes to 360. So this comes from here, this comes from here, and this part is the number of sides. Okay? All right. Here is a hexagonal pyramid. So think about this. What do you need? Okay, so the hexagonal pyramid is a little bit different because, well, first our base isn't the same. So now you got to think back a little bit. The base is a hexagon. So remember, you got to take the 360 divided by, in this case, 6, which is 60. That's my central angle. Okay, so that's where I came up with this. It's an isosceles triangle. Well, it's actually an equilateral triangle. And so if I knew that the side length was 10, I know that the radius is also 10. So now I can use a little 1/2 AB sine of C. Okay? So now I can go ahead and find the rest of my triangle. Now, you also need the side lengths, or the sides, which in this case has a height of 22, slant height of 22, and a base of 10. But then think about how many of those you need. I'll let you try it. See if you can figure it out. Okay, so here we should have had 1/2 10 times 10 times sine of 60 from from this slide right here. Okay, so that's 259. Each triangle is 1/2 times 10 times 22. And there are 6 of those in this case because it's a hexagon. So now I'm going to take my 6 triangles and add it to my base to come up with my surface area. Okay, that's what you need to know about finding surface area of a pyramid.